Alright, hey everybody, this is Jay Helix again, coming at you with another video for the LT4 swap install series. And in this video we're going to talk about spark plugs. So the big thing is, which spark plugs should I use? There's lots of different options out there, obviously. We can stick with the GM original equipment spark plugs out there from AC Delco, NGK, E3, Champion. I mean, there's just a total plethora of different spark plugs. And since I'm doing a force induction on my LT3 application, the main thing that I'm focused on is making sure I minimize pre-ignition and knock. And so with that, you know, one of the deductive reasoning steps is to help kind of navigate through the waters of all the different spark plugs out there is you know, coming on a manufacturer and then ultimately coming down to the heat range that I should go with for a particular spark plug. So the problem statement being, you know, which spark plug should I use? You know, I could stick with what I already have in the LT3 truck. I can which is actually the E3 spark plug right now. I can go back to the LT3 stock spark plug, or I can try something different. So the goal of this video is to kind of walk with me through my reasoning and some of the thought process I have behind of getting down to a particular spark plug for this application, with the end goal being that I want to minimize any type of pre-ignition that might happen and potentially any knock. So with that, I think a good place to start, you know, going back to deductive reasoning is well, what do they use? What does GM use out of the factory for these LT4 applications? So if you guys remember from the previous videos, I'm using a LT4 Supercharger, my earlier model Supercharger, the shorter snout, off of a 2015 Z06. This Z06 has got 40,000 miles. So I have the service manual pulled up here, so I'm currently logged into, and this is something we talked about in the references video, but I am logged into AC Delco TDS. So I'm looking at the service manual for this 2015 Corvette, and I want to just see what part numbers they have or what spark plugs they recommend. So let's go do that now. Let's see, I'm going to go to replacement parts here. All right, so here we go. So I'm inside the maintenance replacement parts here. So air filters, oil filters, and spark plugs, all that fun stuff here. So what we have is the GM part number, and then also the AC Delco part number. So this is pretty interesting here. So they give us the part number for the LT1 engine, so that's just the 6.2 without the supercharger, and then also the part number here for the supercharger, the LT4 option. So it looks like I can either use a 114 or a 128. Now, one thing that I already know off the bat here is this 114. So this spark plug is actually shared between the LT3, LT6, as well as we can see here the LT1. So these all have utilize the same spark plug. And so all things being equal, that most likely means also the same air gap. So what I'm interested in is this 128. So we got a good start here. You know, we are basically going to find a kind of a place to begin, which is, hey, let's just choose what GM recommended for the OE part for spark plug for LT4. But what I need to know is the specifications for these spark plugs, and we can get that. So funny enough, let's see, the AC Delco here does have the parts catalog you can go to. So this is the US site. Unfortunately, it's not very helpful. It doesn't provide the specifications I'm looking for, but oddly enough, You can look at the same website, but this is actually, if you see up here, this is actually AC Delco of Arabia. Everything's in U.S. customary units. You know, the part numbers are all the same. It's just, you know, apparently this is what they use for Arabia. So what I did here ahead of time is I went ahead and, so I'm looking at the parts catalog here for AC Delco. So this is obviously online. So I got the 2015 Chevrolet Corvette, and I'm looking at the spark plugs. And then over here in these filters, I went ahead and applied the LT4 filter and the LT1 filter. So here I can verify that the 114 matches what we saw over here in the service manuals, 114, 128. So here I got 114 selected, and then also the 1128. So what's really neat about this though is, you know, this is AC Delco's information. I have the specifications right here. So lots of cool information here. So they give you, you know, the insulator height, or pre-grep size, but most importantly, this heat range value. And this might be a good segue to talk a little about how we can interpret these specifications. You know, to be able to understand these specifications and how they apply and how they impact the application, we need to understand a kind of the basic anatomy of a spark plug. So before we really start going into these, let's do that. Let's spend a few minutes going over the spark plug anatomy. And I found a really good resource for that type of information is NGK. They have a lot of good information about just about anything you can think of related to spark plugs. So I kind of like this diagram. You know, you have the basic spark plug here in the middle with a little bit of a cross section, and granted, you know, a lot of this information here is going to apply specifically to NGK, but there is some carryover information that goes across brands, and some of the basics is what we'll focus on. So obviously, and forgive me if you know, obviously if you guys know this, but just to make sure we're all on the same page and aligned, so we have the spark plug insulator itself, the ceramic insulator. So you can see that stretches from the piece that we see outside of the cylinder head that the actual spark plug boot goes onto, and continues all the way down into the part that screws into the cylinder head inside the combustion chamber. So that overall is what we call the insulator, and is generally made from ceramic. So inside that insulator, surrounding the insulator surrounding a core or the center electrode, and this material can be made from the core can be made from different materials, but most commonly you'll see copper. We're not going to go through all of this. We're just going to pick out some of the most important pieces. And then obviously have our ground strap here, so our ground electrode, and you have some different setups, different ways that these can be configured. So the center electrode here, you know, there's different type of projections that it can come in. I meant the insulator. It can come in some different projections. The center electrode's got some different options that you can buy those in. So one of the common ones that I think nowadays we see is this fine wire. You know, the ground strap setup. This is also something that we see across different manufacturers. They have different ways they do ground straps. So like, for example, E3, they kind of use a multi-ground for their ground straps. NGK also has, as we can see here, an option for that. But anyways, this is just some basics, basic anatomy of our spark plug here. So what we're really interested in though is the heat range. So NGK does also have some good information on the heat range, and really what we want to understand is kind of the thermodynamic properties and how they play into a spark plug when it comes with combustion. So what this really comes down to is obviously the knock and pre-ignition. So we're obviously focused on trying to eliminate as much of that as we can, and a lot of that depends on the heat range of the plug, but more specifically the some of the thermodynamic properties that the plug offers to us. Excuse me. And that can come about in some different ways. It's one. It could be how the surface area of the plug itself, the piece is actually inside the combustion chamber, the type of material that the ceramic and the insulator is made from. They're all going to have some different type of thermodynamic characteristics that, for better or for worse, conduct poorly or product good for thermal heat. So what we're trying to do is basically, and that's why I like this illustration here, is this showing kind of the heat flow. So here at the bottom is obviously our combustion chamber, and what we can see is the majority of our heat is being transferred. So this piece here in the middle is our cylinder head, but the majority of that heat is inside this thread reach region. And so this is the lower part of our plug. So here we got during the combustion process, we actually generate a lot of heat. And with that, the pieces that are in the combustion chamber are also experiencing a lot of heat. A lot of heat is being thermally transferred to those pieces. And we want to conduct some of that heat away into the cylinder head where the cooling system can take that heat and move it on through its process. So that way this tip doesn't get too hot. If this hit, like what we know already, if this tip gets too hot, that can cause pre-ignition, and that can also cause knock. So we're trying to find that balance. And so that's where we get into some terminology of like a hot plug versus a cold plug. So with a cold plug, basically what that means is we have very high heat transfer. So the tip can stay, or the nose here of this electrode can conduct heat very quickly into the cylinder head, compared to a hotter plug. And a hotter plug means that the heat path flow is generally a little bit longer. So generally, in the extremes of a hot plug versus a cold plug, your hot plug might have a longer snout here, or nose. Actually, that can probably be seen down here. So here we have a cold plug versus a hot plug. And I would look at this as extreme, kind of maybe the extreme situations if you wanted to see it physically on a plug. But you can see our heat path to the cylinder head, in this case, is much shorter. So that surface area and some other characteristics, the heat path is a lot shorter compared to how the heat's got to travel with this longer nose. So now that we know that about the heat range, let's get back to, and we know a little bit about the basic anatomy of a plug. Let's kind of go back to now our AC Delco plugs here. One thing to keep in mind about heat ranges is that the scale that manufacturers use, they're not universal. Everybody's going to have their own numbering system. It could be from a scale of 0 to 9. It could be 0 to 20, 1 to 10. They're all going to be different. So you're going to have to really do your due diligence on finding that information from a reputable manufacturer of the spark plug you're going to be purchasing them from. So for NGK, they make that pretty publicly available of how their heat ranges are characterized. And one other thing to note too is kind of like what they're saying here. A good rule of thumb is for every 75 to 100 horsepower added, we want to go to at least one heat range cooler. And that kind of makes sense, right? Because the more horsepower you're adding, the more energy you're putting into that cylinder, the more pressure, the more heat that's going to be generated. So you're going to want to be conscientious of that and make sure that some of that is dissipated quicker compared to what you had before. So for our application, we're definitely going to be up in this 100 horsepower range. So, it sounds like I should be at least going at least a little bit one step down, or one step colder when it comes to the heat the heat range. So anyways, going back to our scaling system here. So I'm not too sure about how AC Delco does their heat ranges. I have seen some older documentation where they believe the smaller the number, the hotter the plug. So we can see here that for this 114, so this would be the stock spark plug that would come on the LT3, LT6, and then in this case the LT1. This is in comparison to the spark plug that's going to come on the LT4 Supercharged applications is going to be a little bit hotter. So this one's got a value of 20. So to me, so far we're looking pretty good. So I'm going back a little bit where we're started off at a point where, okay, for Z06s that are out there on the road, it looks like they're using a little bit colder plug compared to what their LT1 counterparts are using. So that's most likely what I want to do too. So now we got a couple options. I got some options on the manufacturer types that I want to use, and also one thing too to note here is with this, the air gap is going to be a little bit different. So for the LT4, this one's you can see here is 31, and see the 114. Where was that? I wish the pre-gap size is 40. So that's also something that I want to make sure to keep in mind. So now the question is, you know, if I was gonna stick with AC Delco and go with this Iridium spark plug, it seems like it'd be pretty simple. I'd just grab a 128, order one of those, 8 of those, and throw them into the truck. But I actually like to stick with my E3 spark plug. You know, I've kind of come to like that mainly from, you know, the fuel economy standpoint, and what we talked about in previous videos about the E3s and why I went with that. Unfortunately, though, E3 doesn't publish this type of information. They really don't have heat ranges publicly available that we can go to. Most likely we need to call them for my application, and in fact they don't even provide an option for LT4. So if you wanted to go purchase an E3 spark plug for a Z06, they don't really have an option for you unless you call them directly. So just out of curiosity, I wanted to go and see what NGK, what options they have, because that's obviously another really big manufacturer that provides a whole slew of spark plugs. So being that AC Delco recommends for their OE spark plug, we want to stick with Iridium, so I'm going to do that with NGK here. So we'll just kind of, I already have one set up. We'll just walk through this one in comparison. So we're at the part finder here at NGK's site, and we're going to stick with the application that my Supercharger came off of. So we have the 2015 Chevrolet. We're going to do the Corvette and the 6.2 liter, and all we're interested in is spark plugs. So we have some different choices here. We got the lithium 9 and the laser iridium, or sorry, the iridium 9 and the laser iridium spark plug. So I'm gonna go with this laser iridium because it looks like this is what this has got some OE equivalents. This is probably what you would use if you wanted to have an equivalent to the AC Delco 114 and 128s. So the one that I have pulled up here is the 5E11, which is the naturally aspirated one. So that's the one that's on the LT1. So let's grab this guy. So this is the one that they'd recommend for the LT4. So one thing we can notice here is they also have similar specifications as compared to what we saw over here with AC Delco. So meaning, you know, the height, the thread reach, heat ranges, spark plug, air gap. Now, like we mentioned before, since the heat range values scales that are used by manufacturers aren't universal, I can't just say, oh, okay, this is a 20, which is, you know, I can't expect this to be a 20. But one thing I wanted to point out here is something interesting. So what I want to start with is this. So you can see for we have two different part numbers for the LT1 and LT4, and you know, generally when you're creating part numbers, the reason you're doing that is because there's differences. So you might have a part that looks identical, but maybe it's off by a digit or however they want to assign it, because something has varied from the other part. And so here a couple things have varied. If we wanted to really drill through these specs, you'll see a lot of these are the same, but the two big things that different are this heat range and the gap, the air gap. So And that makes sense, right? When we have a part number that has, even though these plugs for the most part look the same, there's enough difference here to make them unique. So you have unique part numbers, and mainly the spark plug gap and the heat range. Now, if we go back over to NGK, so so let's keep in mind that for this LT1 application, the 114, this is going to have a hotter plug. So this is a 16, and we're not going to focus really on what the actual value is. Just keep in mind that the LT1 has a hotter plug versus what the LT4 has. LT4 has a cooler plug, and like we said before, that makes sense. But if we go back over to NGK, so here we're looking at the 5E11. So this is our LT1 spark plug, and what we just selected over here was our R5D, and this is our LT4 application. Let's look at this heat range. So for the LT4, we have a 5. So logically, what would I expect? I would expect that, okay, I know from AC Delco's part numbers and their specifications that the LT4 spark plug is a little bit cooler than what the LT1 has. So I'd expect if I come over to the LT1, it'd have a cooler heat range. Well, it doesn't. It's got the same heat range. Everything else is pretty much the same. You know, we look at, for example, the reach. That's 25 millimeters. The reach here is 25 millimeters. Resistance, 5,000 ohms. I mean, all this other stuff, thread diameter, all that's the same. The core material, the really only difference is our pre-gap size. So 44 versus 36, which kind of jives with what we've seen over at AC Delco, so they kept that. But for whatever reason, NGK decided to use the same heat range for both applications, for an LT1 and LT4. So that's kind of throws a little bit of a wrench into the situation, because if I wanted to not use an AC Delco spark plug, but I wanted to go with another manufacturer, makes me wonder now, well, why did they decide, in this case, NGK, to use the same heat range where AC Delco decided to have actually a colder plug and heat range versus in an LT4 versus a much hotter heat range for the LT1. So kind of puts me in a spot where I might expect that for other manufacturers that provide this. But I thought that was really interesting. You know, outside of the only difference here being the gap size, our heat range is really everything's the same except for the gap size. So I think what that now requires me to do, or what we're just, my own curiosity is, I'd like to understand a little bit more about, because essentially these seem to be almost identical part numbers. Like, I don't even understand why they have different part numbers when, well, actually, yeah, I do, because what's different is the gap size. But that seems kind of silly that we have essentially two different part numbers, but the only really difference is that gap size and not the not the heat range. And I have some doubts about that, if that's going to be safe. So basically, what the next step for me is going to be is I actually purchased these plugs. So I purchased the plugs from NGK for LT1, LT4, and I actually purchased not just the laser iridium that we saw here. We'll go back to that real quick here. So let's see, Chevrolet, and we're doing a Corvette 6.2, and we're just in the spark plugs. So I went ahead and purchased this laser iridium, and then also the iridium 9 spark plugs. And the only two options there were the supercharged and non-supercharged. And I purchased the E3 spark plug for the stock recommendation for the L83, and then I also purchased the LT1 and LT4. And kind of what we know back on what we've seen over here, one of the things for heat range is, the big thing is the surface area. One way, and there's different ways we can increase that surface area. It could be the diameter, it could be the length. And I realize that this is more for a visual reference, but I would expect maybe that the snout, including the projection, would be a little bit longer in a hotter plug versus a colder plug with the AC Delco. Obviously, for the NGK part numbers, that's probably not going to, maybe not be the case. So what we're going to do next is we're going to tear some of these plugs apart and just do some measurements and see if we can kind of see if really we can detect a difference between these two, or really are these specifications not 100% accurate, meaning in reality maybe NGK is being honest and saying, hey, the heat ranges are identical and the only thing that's different is the spark plug gap. And maybe that's the case here with AC Delco radium plugs, is really the heat range is identical and the only difference being the spark plug gap to justify having separate part numbers. So what we're going to do is we'll come back to we'll go out to the garage and come back to this with the different spark plugs that I got, and we'll start doing some disassemblies of those and taking some basic measurements based off what we know with the with some of the spark plug anatomy concepts, and using the specifications that we have, some of the specifications that we have here from AC Delco and NGK, to see if we can actually see if there is any differences. Because at the end of the day, you know, we still have the problem statement is which spark plug should I go with, and I'd like to stick with E3. So maybe through some of that discovery, we can understand if E3 would suffice, the LT4 E3s that I have in there today, and not have to worry about pre-ignition and knock. So so that's what we're going to do. We're going to grab the NGKs that I have. We'll disassemble those. We'll disassemble the E3, and we'll disassemble the two different part number AC Delco plugs and do some measurements. So let's do that, and we'll come back and continue this.